This statement sets the context for the problem. We're using a technique called KFold cross-validation, which is a way to split data into multiple subsets for training and testing a machine learning model. In this specific scenario, we have 25 samples of data and are dividing them into 5 folds, or groups. This is a common technique to evaluate model performance. Think of it like splitting a deck of cards into 5 smaller piles. This introduces the quiz question, which tests understanding of how KFold works. We need to evaluate the truth of several statements related to how the data is split and what properties result from that splitting. This is the core of the problem. It describes the scenario. Using the KFold function in the scikit-learn library, a popular Python library for machine learning, to split 25 data samples into 5 folds for cross-validation. Cross-validation is a way to make sure our machine learning model generalizes well to new data, not just the data it was trained on. This statement suggests that each of the 5 folds will have precisely 5 samples. 25 samples, 5 folds equals 5 samples per fold. This statement describes that each data point will be used exactly once as a test sample, and will appear in 4 other training sets. This discusses the concept of stratification, which means that the class distribution, if the data has labels, is similar across all folds. It mentions the "shuffle equals true" and "random underscore state" parameters, which control the randomization of data before splitting. Stratification is important to ensure a fair evaluation of the model. This statement explores the effect of shuffling the data before splitting. Shuffling helps to make sure the folds are more representative of the entire dataset. This simply labels the following list of samples. It clarifies that we are dealing with 25 individual data points. This shows a representation of the 25 data samples. Each sample represents a single data point that will be included in the cross-validation process. These rows simply represent the 5 folds created by the KFold cross-validation technique. Imagine you're splitting a deck of cards into 5 piles. These are those piles. This is the first of the 5 folds. In one iteration of the cross-validation process, this fold will be used as the test set, and the remaining folds, 2, 3, 4, and 5, will be combined to form the training set. Similarly to fold 1, this is another fold. In a different iteration, fold 2 becomes the test set, while folds 1, 3, 4, and 5 create the training set. This continues for each of the 5 folds. Fold 3 serves the same purpose as the previous folds. In its turn it is used as the test set, with the other folds forming the training set. Think of it as rotating the test set. Same as above, in a subsequent iteration, fold 4 becomes the test set, with folds 1, 2, 3, and 5 serving as the training data. Finally, fold 5 becomes the test set for the last iteration. The remaining folds form the training data. Each sample from the initial dataset appears in exactly 1 test set and 4 training sets across all the iterations. Okay, let's break down what these folds represent in the context of 5-fold cross-validation. Imagine you have 25 data points. KFold divides these into 5 groups. 5 folds *, each used once as a test set. The remaining 4 folds always form the training set for that test set. So, fold 1 would be a test set, and the rest are the training set. Then fold 2 becomes the test set, and so on. It's like a round-robin tournament for your data. This question is all about testing your knowledge of how KFold in scikit-learn works in practice. We're using it for cross-validation, a clever technique to get a more robust estimate of your model's performance by training and testing on different subsets of data. While KFold aims for roughly equal-sized folds, 25 samples, 5 folds equals 5 samples per fold. This isn't a guarantee. It depends on how the data is organized. It might not be perfectly divisible, leading to slightly different fold sizes. Think of it like dividing 25 cookies among 5 friends. You aim for 5 cookies each, but you might end up with some friends having 4 and others 6. This is the core idea of KFold. In each round of cross-validation, every data point takes a turn as a test sample, while the rest are used for training. It's all about making the most efficient use of the available data for evaluation. Shuffling the data before applying KFold makes the folds more random, making it more likely each fold represents the entire dataset's class distribution. However, it doesn't guarantee it. For a guaranteed similar distribution across folds, you'd use stratified KFold, which explicitly accounts for class proportions. This simply refers to the data you are working with 25 separate data points or observations. They might represent things like customer profiles, images, or measurements, each with certain features and possibly a class label. This specifies the cross-validation method used, KFold with k equals 5, indicating 5 folds will be created. Each fold is a subset of the original dataset. This is the title of our problem, focusing on understanding how KFold works in scikit-learn, a popular machine learning library in Python. We're dealing with a cross-validation technique to evaluate the performance of a model without using all the data for training. The core question sets the stage. We're using KFold, k equals 5 meaning 5 folds, a method to split our data into 5 groups. This method is used to validate the model's generalization ability by repeatedly training and testing it on different parts of the data. This statement suggests each of the 5 folds will have exactly 5 samples, 25 total samples, 5 folds equals 5 samples per fold. We need to check if this is always true with KFold. This statement claims each data point participates once as a test sample and several times as a training sample across the 5 iterations. Stratification means maintaining the proportion of classes in each fold. This statement asks if KFold automatically stratifies, ensures balanced class representation in each fold, without explicit instructions like !shuffle equals true randomizing data, and !random_state setting a seed for reproducibility. This statement tests the understanding of !shuffle equals true s effect. Does it guarantee similar class distribution across folds, meaning similar representation of classes in each fold? We have a total of 25 data points to work with in our analysis. We are using a 5-fold cross-validation, meaning the data will be divided into 5 groups, each serving as a test set once. This describes the setup of the problem. We're using a technique called cross-validation, which is a way to divide our dataset to evaluate a machine learning model. We have a dataset with 25 samples and want to divide it into 5 groups, or folds, to train and test our model. The goal is to understand how the data is split and what properties these folds have. K stands for the number of folds. In this case, it's 5. The next few rows will help us analyze each of the statements about this process. This introduces the core question. What are the true statements about how the data is split using 5-fold cross-validation? It will help us focus our analysis and understand the specific points to check regarding the characteristics of the fold generation. Is a specific implementation of KFold cross-validation in the Python library scikit-learn, a popular library for machine learning. The problem states that a dataset with 25 samples is used and 5 folds need to be created. This sets the stage for evaluating the truth of the statements in the following rows, regarding characteristics of how the folds are created. This statement claims that each fold will have exactly 5 samples, 25 samples, 5 folds equals 5 samples, fold. We need to check if KFold guarantees this perfect division or if it's just an approximation. This is an important question for understanding the balance and fairness among folds. This statement describes the fundamental nature of KFold. It says that each sample will be in the test set exactly once and in the training set for the other 4 folds. This is key for unbiased model evaluation, as we evaluate the model on each sample once, having never seen this particular sample during training. Here we are checking if a technique called stratification is automatically applied. Stratification ensures that the proportion of different classes, if the data is labeled, is similar in each fold. The statement claims this happens by default without shuffling. We need to figure out if this is true or not. This statement investigates the effect of shuffling before splitting. Shuffling randomizes the order of samples, which ideally should lead to a more even distribution of classes across folds. It claims that this will guarantee a similar distribution, which needs to be verified. The question here is whether it truly guarantees this or only improves the chances. This question explores how scikit-learn's KFold works for cross-validation. It's a technique to divide data into *k. In this case, 5 groups called folds, each used once as a test set while the others become training data. We'll analyze the implications of different parameters and assumptions about the dataset. While KFold aims for equal-sized folds, 25 samples, 5 folds equals 5 samples per fold. It's not guaranteed. The actual sample counts in each fold might vary slightly due to how the samples are divided. This is a core principle of KFold. Each data point will be in one and only one test fold and will participate in the training sets of the remaining folds during the cross-validation process. It's a defining characteristic of the method. No, KFold doesn't automatically stratify. Stratification keeps the class proportions similar across folds. Without shuffling, shuffle equals true and a random seed, random_state folds are created sequentially. This can lead to unequal class distributions in the folds if the data's inherent ordering has a relationship to the class labels. We need to explicitly state stratification if it's required. While shuffle equals true randomizes data before splitting, it doesn't guarantee equal class distributions. That's because even after shuffling, there's a possibility that similar classes might cluster together if the data wasn't shuffled enough initially. To ensure similar class distribution across the folds, stratified KFold should be used instead. The dataset contains 25 samples, which will be divided into 5 folds for cross-validation. This is the foundation of our analysis. This specifies that KFold cross-validation will be performed using 5 folds. Each fold will be used once as the testing set, one of the 5 partitions of the dataset. It will be used as the testing set once, and it will become part of the training set in 4 other iterations. Another partition of the dataset, serving the same role as fold 1 in cross-validation. We are splitting our dataset into different subsets and testing their interactions. Similar to fold 1 and fold 2, each fold plays a crucial role in ensuring a robust evaluation of the model. Yet another partition of the dataset that will be used for testing and training in the same pattern. Think of it as a rigorous examination of your model, the final partition of the dataset. After processing fold 5, the cross-validation process will be complete. This sets up the problem. We're using the scikit-learn library's KFold function to perform 5-fold cross-validation on a dataset comprising 25 samples. This means we will split the data into 5 groups, then take one group as testing and use the rest as training sets for 5 rounds of evaluation. This statement explores whether each fold will have an exactly equal number of samples, 25 samples, 5 folds equals 5 samples, fold. While the aim is equal-sized folds, is this truly guaranteed? This proposes that each sample will appear exactly once in the testing set across all 5 folds and as part of the training set in the remaining 4 folds. Let's consider if this aligns with the function of KFold. This statement examines whether folds are stratified, ensuring equal class distribution across folds. If the shuffle and random_state arguments are not specified in the KFold function. What does KFold do by default? This checks if setting shuffle equals true ensures similar class distribution in each fold for labeled datasets. Does shuffling the data prior to splitting guarantee a similar class distribution across the folds? The method used for evaluation is 5-fold cross-validation, which uses the KFold approach. We will be dividing the data into 5 folds, each of which will take a turn as a test set.